Okay, good afternoon. I'm Derek Levington with Empath Engagement. I'll be your host and moderator today, and a warm welcome to all of you joining our webinar, Power and the Environment, Impacts, Trade-offs, and Making Sound Choices. I'll be introducing all of our panelists shortly, and we have four joining us today. But meet Allison. Allison, could you offer a land acknowledgement as we start off the session here?
For sure. SaskPower's work reaches the ancestral lands of many nations. This includes the nations on Treaty 2, 4, 5, 6, 8, and 10 territories, as well as the Dakota and Métis nations. We reaffirm our relationship with the peoples of these lands and honor our shared determination to preserve the lands for generations to come. Personally, I'm with you today from Regina, Saskatchewan on Treaty 4 territory, where I live, work, am involved in my community, and raise my family. Recently, I was on a trip between Regina and Saskatoon for a conference there, and I took note of the sign that transitions from Treaty 4 to Treaty 6 into those areas, and I took note of what that might mean for the people of Saskatchewan today and what it might have meant in history. For those of you that are in Treaty 4 or other areas of the province or potentially other areas across Canada, we encourage you to take a moment to acknowledge the land that you're on today.
Great, thanks, Allison. So a bit of background. SaskPower is in the process of updating its long-term power supply plan. And of course, that plan needs to deliver cost-effective, reliable power service, and that meets greenhouse gas emissions targets. So I guess the question is, how do we get there? That's really what this future supply plan engagement process is all about. It's a 5-stage process, and SaskPower is looking for input at each stage. So during the second stage of the engagement process, and you can see that there, that concluded earlier this year, what we heard is that participants wanted more information on some of the details, the cost of power. What are some of those broader life cycle environmental trade-offs and others? And so we're happy to report that in that second stage alone, there's over 15,000 customers that participated in completing the survey. And of course, if you want to hear the kind of things that SaskPower is hearing through this process, you can do that at saskpower.com/engage. And some of the input that we're hearing through this process is part of why we've selected, and we're also bringing you this information today. So of course, we brought together 4 panelists who I will introduce shortly. And again, we'll be looking at this whole topic of power and the environment. Again, just making the best possible choices. Just a couple of practical things here. For today's webinar, we'll be using a couple of features. The chat feature is there. It's really primarily there for support. So if you can't hear someone, we will do the best that we can from where we are to help you and aid in your participation. And at certain points to the webinar, and you'll know those because I'll point them out, there'll be a chance to ask some questions to some of our panelists. And again, we'll be reviewing those, and I will be taking those questions, kind of putting them together, and then posing them as questions to our panelists here today. So again, there'll be a couple of points, and you'll know those because I'll point them out throughout the presentation. If you have to step away, or you think this is something that you'd like to look at again or share with someone else, everything's recorded on here. And this is going to be shared later on SaskPower's YouTube channel. So if you miss something or you have to step away, you'll still have a chance to check out the content. So with that, I'm going to introduce some of the rest of our panelists here, and you'll see them. They'll come on here shortly. I'll start with Allison, who you briefly met. Allison is the Manager of Nuclear Regulatory Affairs at SaskPower. She's an environment management professional with over 15 years of experience in environmental assessment, federal and provincial regulatory applications, and strategic advisement. Allison led the environmental program and regulatory applications for 55 of SaskPower's major transmission and energy production projects, including the longest transmission line in southern Saskatchewan. Allison has a passion for conservation and specializes in native prairie ecosystems. Next is Bruce. Hi, Bruce. Bruce joined SaskPower in 2013 and leads the Environmental Strategic Issues Management Team in the Environment and Sustainability Department. In this role, Bruce and his team are responsible for identifying environmental legislation that impacts SaskPower and developing strategies to ensure compliance. Bruce has over 25 years of public service experience in Saskatchewan, including work with the Saskatchewan Ministry of Environment, managing the provincial sport fishery, and developing provincial fisheries legislation. Next is Nathan. Nathan hails from Saskatchewan and is SaskPower's Director of SaskPower's Environment and Sustainability Department. He has over 20 years of environmental experience, with 15 of those at SaskPower. Nathan earned both his Bachelor's of Applied Science in Environmental Systems Engineering and Master's of Business Administration from the University of Regina. He's a professional engineer and a member of the Association of Professional Engineers and Geoscientists of Saskatchewan. And Jennifer. Jennifer has worked in the Environment and Sustainability Department at SaskPower since 2008. She's currently the Manager of Environmental Assessment and Approvals. Her team plays a vital role leading the environmental assessment and regulatory permitting activities for SaskPower projects. Jennifer holds a master's degree in environmental studies from Dalhousie University and a Bachelor of Science degree in biology from the University of Victoria. So welcome to all of you. This is the group that will be speaking to us today. So let's start off with a quick poll just to sort of see what's kind of top of mind for those of us that are attending here. So you should see that popped up on your screen there. I'll just read the questions out and give you a moment to quickly think through those and respond. So which aspect of environmental performance is most important to you that are listening today? So we've got emissions reduction, enabling efficiency and conservation, minimizing impacts to water and wildlife, recyclability of materials, and effective land use. Obviously, that's not a comprehensive list. As you'll learn today, there's lots of other aspects to this, but I think we're curious to know what's top of mind for everyone who's listening. We'll give you another moment to think about it and enter your response, and then I will share some of the results back with you. So here we go. Going, gone. 3, 2, 1. I'll end the poll, and we'll see where we landed. So here's some of our results. So on the top of that list, emissions reduction, number one. Almost half of participants indicated that one. Next one, enabling efficiency and conservation. Minimizing impact to wildlife and water. That's one of the ones we hear is a really important area. Effective land use. And the last one on the list, but certainly not an unimportant aspect, is the recyclability of materials. So thanks for your participation on that. Okay, well, let's start into some questions here. And Nathan, I will direct this first question to you if you want to get ready. So from your perspective as the Director of Environment and Sustainability, why does SaskPower's environmental work matter?
So we're doing more work in the province than we ever have before, and we fully recognize that it's SaskPower's responsibility to consider the environmental impacts of our operations and do everything we can to mitigate those impacts. We are important stewards in the province for the environment, and we recognize that our customers have a very high expectation that we will be responsible. So that means, of course, complying with environmental regulations, but also looking for opportunities to go beyond compliance.
Okay, so who's doing all the work at SaskPower?
So at SaskPower, our environment and sustainability team includes approximately 50 employees located across the province. We have a wonderful team with many different environmental backgrounds. We have archaeologists, biologists, engineers. Another thing we do, because there just is so much work going on, is that we leverage external expertise as well. So external environmental consultants and contractors, when required, we bring them in to support the work that we do.
Nathan, is there a particular project or initiative that SaskPower, takes on that is, of particular importance to you or maybe the team that you work with?
Yeah, I'm particularly proud of the excellent work that we do at the Shand Greenhouse. So the Shand Greenhouse, if you're not familiar with it, is located next to SaskPower's Shand Power Station near Estevan and has been operating since 1991. The Shand Greenhouse grows and gives away approximately 500,000 tree and shrub seedlings every year. Another interesting piece of information about the greenhouse is that it uses waste heat from the power plant to help supplement heating in the winter. So, how do we give those away? There's an application process, and most of those seedlings are given away to rural Saskatchewan landowners for establishing shelter belts on their property. And to date, we've given away over 14 million seedlings since 1991, which we're very proud of. If we talk about emissions, very high level estimates, but we estimate that there's approximately 9 million of those tree and shrubs still living today, and that they can help capture and remove more than 100,000 tons of CO2 every year.
Okay, great. Thank you. Um, we know that customers care a lot about local impacts to water and wildlife. I guess, why are emissions reductions more important than ever to? And it certainly sounds like to the group that we have with us today, that's sort of the top of mind thing for them. So why is that important?
Yeah, so probably my first comment is, of course, regulations are driving SaskPower to reduce our greenhouse gas emissions. We're also seeing the impact that climate change is having across the globe. And I think for those reasons, SaskPower is very committed to reducing our greenhouse gas emissions. So we do set targets. We have a target to reduce our emissions by 50% below 2005 levels by 2030. And so what does that mean? So that would mean our emissions reduced to approximately 7 million tons of annual emissions by 2030, but fully recognizing that that's just the beginning for us as we continue to plan for further emission reductions in the future. For me personally, seeing aggressive emission reductions, is so important and will play such a key part in reducing the environmental impact for current and future generations.
So Nathan, you mentioned net zero. So that's not zero. What do we mean exactly when we say net zero? What kind of unpack the definition of that for us if you can?
Yeah, for sure. Yeah, and I think I mentioned, significant reductions, but you're right. Net zero is what we're, is the conversation that we all hear in the media and elsewhere. So put simply, net zero means you find a balance where carbon that's emitted into the atmosphere is equal to carbon that's removed from it. So, of course, it starts with trying to get as close to zero as you possibly can with your emission reductions. And then for remaining emissions, are there opportunities to remove? And the term you'll hear is offsets. So are there ways to offset any remaining emissions? A couple of examples. So are there management practices that can improve carbon absorbing capacity of the land? Are there ways to further capture greenhouse gases from industrial processes would be a couple of examples of offset.
Okay. Okay, thanks. I'll launch a quick poll here, and this goes in terms of regulation. So, who regulates SaskPower? Kind of a trivia question here. Is it the province, the federal government, or both? I'll skip that one moment here. And the correct answer to that is, it turns out actually both are both levels of government regulate SaskPower. And between the two of them, SaskPower adheres to over 150 sort of separate acts and regulations. So no wonder you folks are busy to keep track of all of those things, because I'm sure they're all changing over time as well. So. Bruce, first question for you. Your group, of course, focuses on staying top of those regulations. What are some ways that SaskPower demonstrates leadership, on these environmental matters?
Yeah, hi Derek. Yeah, like our group, and actually a lot of groups across SaskPower, we're pretty closely engaged with a wide range of environmental regulators. So as the poll suggested, we're dealing with provincial regulators and federal regulators. There's a really wide swath of it. So the leadership I think that we provide is, partly internally, we have a management system that we use to keep track of all these pieces of legislation, understand, where we need to be compliant with it in SAS Power. But I also think, we're pretty proactive in formulating relationships with the regulators. So we have open dialogue with them and talk to them about making sure we're understanding, we have full clarity on the regulations and we're complying with them. And a little bit more so nowadays, actually, with new and emerging regulations coming through, we really work hard to get an understanding of the implications of them and being fully aware of them and plan for it, because they do have impacts for SAS Power for many years to come. But I will say too, like some of the engagement that we have and some of the leadership outcomes we've had, a couple of things come to mind is, we've been working on the PCB, the polychlorinated biphenyls is a chemical that's used in a lot of our equipment. And really over the last 10 years, we've had a program to remove them. And I have a certain sense of pride because our company, the regulations require us to remove some of them, but we've exceeded that. We've gone beyond the environmental requirements or the regulator requirements. So I think that's kind of cool for sure. We work with the regulators on a proactive basis. So as we were expanding more renewable sources of energy like wind, we worked with the province to establish what we call the wind siting guidelines. So where's a good place to put the wind when we're building it? And I think that's been helpful and proactive to sort of set out the areas where we build our wind facilities to avoid impacts to things like birds and bats. And really looking forward, I think with Canada rolling out new regulations, the clean electricity regulations, that's one where we really have to be proactive, engage, and really understand the sense of where Canada's going and how SAS Power can align with that.
So on those clean electricity guidelines, maybe just tell us a little bit, about those regulations because they were released here fairly recently. So
yeah, they're the what I call the jumbo regulation that's coming at us, and I'm sure folks are hearing about it on the news. The slide shows some of the details of how the regulation will apply to every unit that produces electricity that has a greenhouse gas emission from it. But the regulation at a high level really sets out Canada's intent to drive down greenhouse gases across Canada. And there's two key markers there. One is that the intent is to have the Canada economy-wide be net zero by 2050. But the key role and the position that SAS Power plays as an electricity producer is that Canada wants electricity producers to be really at very, very minor greenhouse gas emissions by 2035. And this regulation that was published in mid-August sets out the rules on how much greenhouse gases we'll be able to emit and really lays it out in pretty, it's a comprehensive and challenging piece of regulation that we'll have to comply with. We're dealing with Canada over the next couple of months and have our formal response back to Canada on what we think are the challenges and the opportunities in that regulation, but we'll have that back to them by early November of this year.
Okay, can you talk a little bit about natural gas, using carbon capture technology on natural gas? Can you maybe just talk about how is that sort of contemplated in the legislation? What are you allowed to do with that CO2, that you capture? I mean, can you sell it to someone who's going to use it in the recovery of fossil fuels, or, are there any other kind of potential uses for that as well?
Yeah, so folks might know that we currently use natural gas to create electricity in Saskatchewan. It's a significant portion of our power generation, but the regulation would require us to emit far lower levels of CO2, greenhouse gas, in that emission source by 2035, with some flexibility for a couple older units. So really the regulation as it rolls out would compel us to have carbon capture on those natural gas units to capture that CO2, and we store it underground in geological formations that are secure. The regulation would allow us, as it's currently worded, allow us to sell that CO2 to, say, an oil and gas company that injects it into the ground, and that enhances oil recovery. So that still seems to be allowed. But I think the key thing for SAS Power is recognizing that to meet the very strict and low emission requirements for natural gas, we will have to be employing carbon capture on some of those units.
Okay. How is your area, again, if you're in the realm of sort of monitoring the environment, how are you sort of, projecting, predicting, preparing for maybe other related impacts of climate change, that could affect, that could affect us here? Like, for example, like how might severe weather affect, Saskatchewan's own power grid in the future?
Yeah, that's an interesting one. I mean, if we look around just Canada and even Saskatchewan, we are seeing greater variability in climate, more extreme weather events generally. So we're approaching it from a couple different ways. One is that, as the engineers within SAS Power, they're looking at, hey, what do we need to build and how strong do we need to make it to resist, stronger winds or ice storm events or fires. So a little bit is, the engineering and the designing of our structures. The other one is, contemplating, well, how will the weather change in Saskatchewan? So recently, some of the approaches we've taken is, we've partnered, did a research study through the university, one of the universities in Saskatchewan here, to say, will there be more or less water coming down, say, the North Saskatchewan River system? And if so, does that mean we'll have less water power coming through for our hydro facilities? So we're actively looking at sort of research opportunities like that to better understand. And there's also a fair bit of existing science that will suggest, not only in Saskatchewan but across Canada, how much more weather events, how they might change. We're collecting other data. We were in a meeting yesterday talking about using a type of radar system that gives you very precise elevations for our facilities in certain areas that would predict where low-lying areas might be more at risk of flooding. So we can either avoid those areas when we build new stuff, or make them a little bit more resistant to those climate effects as we go forward.
Okay. I could take a minute here for a couple of questions, and I'll just pop a screen sharing off so you can maybe see everyone's faces a little more clearly. I guess I'll ask this question. I mean, because I think, this is a personal question. I hear people with a lot of really different perspectives on it, but, I mean, how real is climate change? What kind of things that we're seeing can we attribute to climate change? Is everything that we're seeing in terms of weather and patterns, is this all climate change? Or, what's your perspective, I guess, as those who, grew up around here and are used to the weather the way that it is? But, what's kind of the thinking kind of within your team? And then, what's kind of the industry sort of thinking in terms of your professional area of practice?
Yeah, I can take that one, Derek, and share my perspective. It's a great question, and when asked that, I mean, I default to looking for trustworthy sources. So if I can put out there the United Nations Climate Change Branch, who is a leader in climate science, has done a lot of research on the topic. Lot of studies, lots of reports that show, through those independent studies, that a high percentage, like over 90% of scientists agree that humans are responsible for climate change. I think one study I read showed that most of the studies finding over 95% consensus, even in terms of those findings. So that's what I use to help, I guess, answer that question and make my own conclusions on climate change.
Okay. Any other thoughts from anyone else on that? What's the perspective? Anyone else want to add on to that?
No, I was thinking last week we were up at one of our hydro facilities in EB Campbell, touring around one of the federal regulators, and in that tour, so I've been with SAS Power about around 10 years, a little over 10 years, and in that period, some of the the hydrology events that we've seen, like the extreme runoffs and flooding events from heavy rainfalls upstream in Alberta. We've seen those come through the system, and it makes everybody kind of sit up and say, wow, like we haven't seen those kind of surges of events. So, as Nathan mentions, the science is very interesting to look at some really informed information around climate change, but actually seeing it in our backyard, it's we have to be ready for those events and plan and prepare for them. So it's an interesting time for sure.
I think one question, and maybe this goes related to some of the nuclear pieces. So, Allison, you may want to speak to this, but what kind of things do you need to be paying attention to in terms of cooling? With some of the water bodies, if we ended up with less rain or more rain, how might that affect cooling? And I know we'll be talking a little bit about nuclear later, but just any comments on that, Allison, for things we need to be watching for?
Yeah, I think from the nuclear perspective, we need to go through an impact assessment process for our project, and those things around climate change are items that need to be addressed through those regulations and those applications. So we will have to be doing modeling and thinking about, the history and what projections on where it goes forward, and taking those into consideration as we're planning nuclear or any other generation, actually. So.
Okay. I guess another question. You've got these sort of competing priorities. You've got regulations. I mean, those are the things that are required, but also you're trying to balance any of these other things. Any sort of comments, on, how do we balance these things off, especially when they kind of compete with each other?
I'll throw a comment out there. I just maybe it's my training and background as a biologist, but I've always kind of been a big fan of balance, right? And I think I like the approach that we look at in terms of having a balanced approach. There's no perfect fit for things, and having a spread of different generation sources and options for us. I think that's one of the strengths of being in Saskatchewan, where there is no magic bullet for the perfect approach, but the more diversity we have in our portfolio, I think that makes us stronger and a little bit less at risk of change as we go forward. So that's kind of an observation I've got.
Okay. I'm going to pop a poll up here, and then we'll continue with some of our sort of our material here. But just kind of a trivia question: which attributes are studied through an environmental lens before new power projects are able to apply for permits? I'll just read them out. So we've got CO2 emissions, or CO2e. We may have to ask for a definition on CO2e at some point here. Land use, water impacts, fuel required, human impacts, impacts to people, the whole idea of decommissioning and reclamation, or all of the above. So I'll just give you one more minute to think about those. Okay, and I'll end the poll there. Okay, well, the spoiler is there were really no wrong answers. But if for those of you that read all the way to the bottom and answered all of the above and more, that's probably the closest to the correct answer there. So all of those areas are certainly studied through an environmental lens before anything can happen. But anyways, yeah, lots of those things, and we'll be unpacking some of those other ones here as well. So, okay, thanks for that. So the topics listed above there, again, show some of those things. Let's look at some of the carbon dioxide sort of aspects of this in terms of emissions. Maybe Bruce, maybe you can just tell us a little bit about what we're looking at here.
Sure. Yeah. So this is just a really high level pie chart that we put together, looking at some of the different supply options that we use. The majority of what we look at currently with these different generation sources is how much CO2 or greenhouse gases will they emit while they're operating. But we'll hear more and more the life cycle cost. So how much greenhouse gases are tied with the front end when we build and acquire the materials, then how much will they emit during operations. And then when we take them down, decommission them, what's the GHG effect? And I saw something pop up there. GHG is a greenhouse gas. So that's a type of gas that when emitted, it'll stay up in the atmosphere. And it tends to trap heat and it has a greenhouse effect to warm the earth. And that's kind of what we're talking about when we say GHGs there. So, but this chart shows the different supply options we have or are considering. And we see the big chunk of the pie is coal. So coal, when we burn it, does emit a lot of CO2 with other elements like natural gas. When we burn that, it does emit CO2, but less. And then we look at those options. If we apply a carbon capture, reduces the amount of CO2. And then we get down to some of the other renewable options we're looking at, like solar and hydro and wind, pretty small greenhouse gas footprints, and then nuclear being the other one that we're looking at. And Allison will probably speak to a little bit more as we go forward here.
Okay. Land use was one of the topics that that sort of showed up at the beginning as being important. So, Jennifer, let's take a look at that and get you to walk us through that. What do we know about footprints of some of the generating facilities?
Yeah, for sure, Derek. In the most simplest form, we know land is needed to generate electricity. How much land depends largely on the type of technology and other limiting factors such as land availability and existing features on the landscape. Take wind, for example. Based on SaskPower's previous experience building a similar sized wind generation facility, it's estimated that one 200 megawatt wind facility with 50 wind turbines in operation can span anywhere between 30 to 40,000 acres of land. However, the actual footprint of the wind turbines and associated infrastructure, such as collector lines and access roads, could take roughly between 100 to 200 acres of land. Solar, on the other hand, according to the Canadian Renewable Energy Association, requires approximately anywhere between 3 to 7 acres of land to generate 1 megawatt of power. Sask Power, for those that don't already know, is currently pursuing the first utility scale 100 megawatt solar project in Saskatchewan. And it's estimated that this will take up approximately 4 to 6 quarter sections of land in the Estevan area, which is roughly 600 to 900 acres. On your slide, there's a little diagram that shows what 160 acres is equivalent to. So for those familiar with Regina, that's basically the area between Albert Street and Broad Street and Victoria Street and College Ave. So for the Estevan Solar Project, we need 4 to 6 times that size of area to accommodate the solar facility. Hydro facilities, on the other hand, require a significantly larger footprint given the amount of flooded area required for a reservoir, and depends on the size of the facility, how much power it will generate, geology and topography of the area. As an example, SaskPower's Nipawin Hydro Dam has an estimated flooded footprint of 37 acres per megawatt of power. And the Nipawin Hydro Dam has 3 units with a combined capacity of 255 megawatts. Other generation types, such as natural gas, SMRs, and biomass, require 160 acres or less for the generation facility site. Given land requirements of the various options and all of the variabilities, it's important that siting of any new generation is a critical step in the planning process. And as we move forward with a rapid large-scale build-out of up to 3,000 megawatts of renewable generation within Saskatchewan, potential impacts to land use will be an important consideration. We're already hearing a lot of concern from farmers and the public in general related to siting new generation, in particular renewable generation, on agriculturally productive land. On the other hand, we're also hearing concerns from environmental nonprofit organizations regarding siting on native landscapes, given they estimate there's only 10 to 12% of native landscapes remaining in the province. So SaskPower and other utilities across North America are currently challenged to balance the competing interests and concerns related to land use.
Okay, so I guess we're kind of talking about things in terms of like, single use. Is there anything that, maybe you can talk to some of this here, what are you seeing in terms of some, kind of innovative ways to solve that, co-locating generation facilities, alongside of agricultural activities, anything around there?
Yeah, given utility scale solar is relatively new to Saskatchewan, and we have yet to build our first large scale solar facility larger than 10 megawatts, we obviously have to learn from other jurisdictions. And in the US, they've been building out solar for the last 10 years. And one area of growing interest are dual use solar installations, also known as agrivoltaics. It allows land to be used for both solar energy and agricultural activities, such as crop or vegetable production and animal grazing. And as solar development grows in Saskatchewan over the coming years, it would be really neat to see this type of dual use solar installation.
Okay. So what type of, I mean, you study the impact of all of these things, what type of power generation has the kind of the, treads the lightest in terms of environmental impact?
In my experience, there is no easy answer to that question because there's too many factors and variabilities to consider, especially when you look at it from a life cycle perspective. What we do know is, regardless of the generation type, whether that be fossil fuels or renewables, there are effects to the environment during a project's lifetime. And so, as part of the regulatory review process, any new generation project at SAS Power must undergo an effects assessment led by my team, the Environmental Assessment and Approvals team, with support from external environmental consultants. And the purpose of that assessment is to understand how the project will interact with the environment, both positively and negatively, and what measures need to be put in place to manage or reduce those environmental effects. The assessment takes into consideration both biological and human effects during all phases of construction, of the project, from planning through to construction and operation, as well as decommissioning at the end of the life. Take, for example, a solar facility. The effects assessment has to examine things such as how will the siting of the solar facility impact wildlife habitat, and how will the security fencing impact wildlife movement through the area? How will vegetation be managed during construction and operation to limit the spread of weeds? How will stormwater be managed during operation to limit offsite impacts to neighboring land? And how will the project be decommissioned at the end of life? And how will solar panels be disposed of or recycled? The challenge, obviously, for SAS Power is to try and understand, and in some cases predict with the newer technologies, the potential environmental risks and effects of each of the generation options as we move forward with the clean energy transition.
Okay, so for saying that every option has some type of trade-off associated with it, like, does that mean that there's waste of some kind? And, basically, can you just sort of talk to what the approach is to handle this whole matter of end of life and for these generation options?
Yeah, you bet. I mean, unfortunately, every project has environmental trade-offs that need to be considered, and how the project will be decommissioned at the end of its operating life and how the environment will be reclaimed is an important consideration. The typical lifespan of most generating projects is anywhere between 20 and 25 years before significant maintenance or overhauls required, or decommissioning. Every power option generation will generate some form of waste that needs to be dealt with at the time of decommissioning, such as removal of on-site buildings and infrastructure, and where possible, obviously recycling materials like scrap metal and concrete. For solar generation, the use of heavy metals in the manufacturing makes disposal and recycling a concern currently. However, it is estimated that solar panels are more than 90% recyclable, and efforts are being made in North America to increase that in order to reduce waste. As far as wind turbines, currently it's estimated that anywhere between 85 to 90% of the turbine materials, such as steel, copper wire, electronics, and gearing, can be recycled or reused. However, the blades have proven harder to recycle and have generally gone to landfill, although efforts are being made to find ways to reduce or reuse the blades. And in North America, wind turbine blade recycling programs are coming into play and are expected to continue to grow as renewables continue to be built out.
Are there any kind of sort of standards right now in terms of, recyclability of, some of the batteries, the lithium ion pieces, anything like that? Where do you see that going in the future?
Currently, there are no regulatory or industry standards for batteries recycling in particular, but we're going to be largely depending on batteries as we move forward with electrification in general. So it's certainly a growing area of research.
Okay. Allison, this is a question for you. And one of the things we've heard a lot about in terms of, potential concerns or just, this whole topic of nuclear waste, it seems like it's kind of a different, animal from some of the other things that we're looking at here. So can you just maybe explain just to the chart up on the screen, what's considered, nuclear byproducts or waste?
Yeah, thanks, Eric. One of the things I like to talk about, even before we get into the nuclear waste aspect things, is just that utility scale nuclear power plants have been operating safely in Canada for over 50 years. There's a number of utilities in Canada. There's Ontario Power Generation, Bruce Power, and both of those are in Ontario, as well as New Brunswick Power, obviously in New Brunswick. So these types of things have been tracked and monitored for over 50 years, like I said before. And also, where some people might not realize is that we do have a federal, internationally recognized Canadian federal regulator called the Canadian Nuclear Safety Commission that helps us, track and store and monitor nuclear level waste. The other thing that I love about nuclear waste, I don't know if people love things about nuclear waste, but
Nuclear
I
waste.
do. Yeah, and one of them is that it's categorized. So there are 3 categories that are recognized in the nuclear space, which is low level waste, intermediate level waste, and high level waste. So the low level waste, if you think of somebody mopping the floor in the plant and you've got the mop head, a light bulb from a facility, all of those things, those type of level of things, they are considered low level waste, meaning that they don't have very much radioactivity associated with them. They are tracked. They are separated appropriately, monitored, and disposed of in a proper manner as per the regulations. Intermediate level activities or products or things that, you have screws and bolts or rods, that kind of thing that may be near the reactor, but not quite like next to the fuel. And the highest level of the highest category is the high level nuclear related fuel, which is your used fuel product. A lot of people think of this as liquid. It's actually a solid, and we'll get into that in the next slide here. But the other thing to really recognize with nuclear waste is, of those 3 categories, that high level waste, which people have the greatest amount of concern for obvious reasons, is the lowest percentage that there is. So 90% of the volume that comes from an operator facility is the low level waste, and you increase in size from there. And like I say, like those gloves, that mop head, that screw is heavily tracked and monitored throughout its life cycle. So I know that light bulb is in that storage bin that went over there for that number of years. And that's because of the regulations that we have in Canada. If you want to flip to the next slide, we can talk a little bit more about that high level nuclear fuel related waste. And it sort of goes through a few different stages, which I think is important to talk about. So we talked about how it's not liquid, it's actually a solid. And each fuel pellet is about the size of a quarter. And it goes into a fuel rod, and those rods come out of the reactor and go into a cooling pond, so a pool of water to go through their cooling process. And once they are ready for dry storage, they get moved into casks. And we've got like a size variant of casks in the next slide, but we won't go there just yet. And then they stay and be managed on site until such a time that they can go to a deep geological repository. And all of that high level waste is managed by the NWMO, the Nuclear Waste Management Organization here in Canada. And there's quite a bit more information around them. But if you want to go to the next slide, I think that those casts are really important. So the used fuel goes into these concrete casts, and you can see the individual standing in the photo here. This is a photo from Ontario Power Generation and one of their used fuel sites that's on their reactor site itself. And it's, you know, a couple, maybe twice the height that this individual is. They're not wearing any PPE related, and that's because of how protective those casts are, that people can walk around and have lunch. And there's actually photos of that out there too, next to the facility. Another top question that we always get around nuclear fuel and high level nuclear fuel is how much waste actually gets is the actual volume. So for one 300 megawatt SMR, for its 60-year life, the used fuel will fit into a double car garage, and that's around the size of amount of volume of used fuel.
Okay, thank you. I guess kind of another question. This is one that I've heard sort of just in the discussions that I've been part of facilitating. But does it make sense, you know, to use some of these renewable options like wind and solar? You know, are they in fact better for the environment? You know, when you kind of take this broader view, you factor in the energy intensity of the manufacturing and this whole topic of recycling these things at the end of the day as well. Does it still make sense?
Yeah, Derek, utility scale battery energy storage is a fairly new technology for Saskatchewan, and we're only beginning to understand it in terms of technology, capabilities, limitations, and environmental effects. We do know that as we grow our renewable fleet, battery energy storage will play an increasingly important role in stabilizing our system and supporting our goal to achieve net zero greenhouse gas emissions as we move forward. SaskPower is currently completing the final stages of our first utility scale battery storage system here in Regina, and that's on track to be in service by December of this year. Once in operation, this system will have the capacity to provide 20 megawatt hours of power to the grid, which equals powering 20,000 homes for an hour. We know, though, that a large amount of raw materials, including metals and non-metals, are used to manufacture batteries, and how these materials are mined and the environmental and human costs associated have to be considered. We're also learning that battery storage systems have the potential for significant environmental risk during operation. If there's a fire, air emissions, including toxic gases, are released due to the burning batteries. There's also potential for ground contamination during fire suppression efforts when water is used to limit the spread of the fire. There are heavy metal considerations associated with the battery disposal and a growing market for recycling. This is a discussion we're seeing around electrification in general and a growth in lithium batteries from electric vehicles. These are all considerations we study and weigh from an environmental perspective to help inform SaskPower decisions. And this perspective is put alongside the non-environmental criteria too, like reliability, human and social factors, and cost.
So how do we know that we're not sort of trading one form of problem for another? I mean, of course, I think we're all a lot of the regulations, they're really clear and prescriptive about reducing, CO2 emissions. Again, how do we know we're not jumping from the frying pan into the fire, with some other, kind of the unintended consequences of our change here? How do we know it's not worse?
Yeah, so I think it starts with just being as informed as we possibly can be, Derek. And you just heard that from Jennifer, and we heard today from a life cycle perspective. So doing everything we can to understand current and emerging technologies, what are the challenges and limitations with those different technologies, and really looking at that life cycle, that cradle to grave impact perspective with the different technologies. So as we do that and we build those considerations into the supply planning, so as we plan our future generation mix, being well-informed going into that process allows us to minimize the risk associated with all of that. So, we're making many of these decisions as well because of regulation. So you do have somewhat of a layer of regulatory oversight pushing us forward as well. So I think, all those elements considered, it allows us to minimize that risk.
Okay. Allison, I'll ask you to speak to this. We've got just some questions about sort of, impacts of water, just concerns about contamination with nuclear. Can you maybe just explain, basically how, water would sort of, would flow through an SMR, when it's adjacent to that, to a water body. So can you just sort of explain that? What kind of impacts would a nuclear facility have on the environment? If you want to maybe get into some details just about, how does that affect, some of the, kind of the chemical sort of makeup, in terms of effects, algae blooms, other things like that. So if maybe to start by maybe explaining just how water interacts with, and then maybe a few more details about the types of things that are studied.
Yeah, sure. So I think the first thing off is, there are about 3 ways that we use water within the facility itself. So, and I would like to coach this off first by saying, like, I'm not an engineer, so this is like my non-engineer version of
Okay,
explaining this.
fair enough.
But so there's the steam cycle to generate power. So that's item number 2, and we'll get into that in a little bit more detail. There's the cooling water for the condenser. So that's item number 4 that we'll talk a little bit about as well. And the third use that we're not going to really get into much, but I think it's worth mentioning, is that there's a domestic use for water. So like, running taps for the washrooms or drinking for the workers that work there. So that, and then as well as like sewage type thing. So there's a little bit of water associated with that. So we talked about like number 2 and number 4 on the screen that you have. Number 2 is a power generation loop. It's a closed loop cycle where water is used it heats up near the reactor, creates steam that turns the turbine that generates power. The steam gets forced down and cools to turn back into water to get the cycle going again. This is a highly monitored system. It has relatively low reaction level that people might think. It's highly contaminated. It's actually not, but it is closely monitored. There's a little bit of makeup water that goes in for, like, if you ever, it gets tested often. It's not meant to be drained. It's meant to continuously be in that cycle, and it's a closed loop. The second system is for that cooling water for the condenser. It has you can get water from 2 different sources. SaskPower hasn't chosen what source it would end up being, either like a water cooling tower that's on site, which is item A, or from a water body itself, which is item B in there. But ideally, you pull water in. It's used to cool that steam down for the cycle, and those 2 systems don't interact. They are completely separate systems. The item number 2 was the closed loop system. Item number 1 isn't, but it's important to understand that those 2 systems don't react together. As far as you were asking around like algae blooms and those types of things, the cooling water system isn't a consumption-based system, so we're not using a ton of water in comparison to some other type of systems that are out there. However, you are rejecting heat, right? So if you're coming next to hot steam cycle, you're pushing out some hotter water, and that does change some of the chemistry and stuff. If it's a shallow system, and Bruce probably could speak to this better than I could, but you could get some algae blooms and that kind of thing. So it's important to study those aspects. And like I said, when we talked earlier in the presentation around the impact assessment, right? Like all of those types of things, all of those modeling that will go out there will go into those level assessments, and those things will all be taken into consideration.
Okay, thanks. I guess maybe a question in terms of, is it possible to think that maybe some of the power facilities, could bring about in some benefit? We've talked a lot about the trade-offs here. I mean, any sort of experiences that we've had so far that suggest that a power facility could have some benefits to it, from an environmental perspective?
Yeah, I'll take a kick at that one, Derek. I think we've talked today a little bit. I mean, there's pros and cons. There's no perfect bullet there, but some of the items we've observed in our existing generation systems, down at I think that's Boundary Dam there pictured with the reservoir. So we take water from the reservoir, we use it to cool down our system, and then the warm water or hot water gets discharged back into that reservoir. And some of the unique environmental effects of that has been, Boundary Reservoir. If anyone's been down there and spent some time, it's a warmer reservoir, and it's enabled the province, for example, in that case, to stock largemouth bass, and they've thrived in that. So it's kind of a unique fishery in the province, and it's one of the side effects. And some of the other hydro facilities that we've got when we create the reservoirs, whether it's Lake Diefenbaker or Tobin Lake Reservoir, those areas, they do support very healthy and productive fisheries that have good economic balance and good recreational opportunities for folks in Saskatchewan there. So there's a balance to everything, but we can find some positive things. We talked a little bit about how we manage our vegetation under our power lines so that we don't just kind of clear out all the vegetation there. We take an integrated approach so that we don't want trees growing underneath our power lines, but we do like to have shrubs and berries and different plants there that are very good and healthy environmental corridors for wildlife and other factors like that.
Okay, thanks. Okay, we've got time for a few questions here, and hopefully some of the questions that you've had maybe have been addressed in the course of the content here. There was one question sort of earlier on just about why were emissions lower in 2020? There was a chart there where we showed some of the emissions. There was a dip. Can you just explain, why did we see that dip in 2020?
Yeah, maybe I'll just speak to that. So basically that was kind of what we call the COVID dip.
Okay.
And it basically, as folks were traveling less, just the demand from our perspective, the demand for power went down. It enabled us to reduce the amount of power we had to generate, and that was really the drop in generation. They have some factors in there too. Some of the years we look at, if we have more water in our system, we can generate more hydropower. In turn, that reduces the amount of reliance on other factors.
Gotcha. Okay. Jennifer, I think this is probably a question for you. What's the expected lifespan for, say, wind turbines and solar panels?
Yeah, typically 20 to 25 years. I mean, obviously, as it's nearing sort of end of life, they would inspect it and see sort of what the condition of the infrastructure is in to see if they can extend the life. But generally, operating lifespan is anywhere between 20 and 25 years.
Okay. I just want to ask a question. I'm not sure who wants to take it. Just, can you comment on the land footprint of using sort of solar rooftop versus, some of the larger scale utility solar?
I don't know that I can speak specifically to the footprint, but I know that rooftop solar, it can't be built out at the scale that we need for the utility scale solar.
Okay.
I don't know if you have anything to add to that, Nathan.
No, I think that's a good answer, Jennifer.
Okay.
Lots of opportunity. We recognize that there's value on both sides with any additional generation on the system. But yeah, when we're talking supply planning and utility scale and the needs we have, that would be why.
Okay. Allison, I think this is a question for you relating to some of the content you chatted about. How are the low and medium level wastes, stored? There's example of the gloves or screws or things like that. How are those dealt with?
Yeah, so they're treated differently because of the categorization that they're in. Low level waste is monitored to such time where it could actually go into like domestic garbage facilities, like you would, the city of Regina or wherever you might live. So it gets monitored for a few years, and once it passes its tests and its monitoring, it can get shipped domestically. The intermediate level waste, there's a couple of different ways that it gets managed. currently in Canada. One of those ways is like on-site incineration type processes. So it just sort of depends on how the utility wants to manage those and what options are available in and around the jurisdiction that's there. So there's a couple of different things that happen with it.
Okay. Okay, thanks. I'm going to run through just a couple of sort of things here at the end. By the way, I've just popped on an evaluation. There's 3 questions there. I guess what we're curious about is, did you learn something new? Just kind of an indication of your overall level of satisfaction. I think we could have gone on longer, but an hour goes by pretty quick for answering questions. So I hope that we were able to get at least to most of them. We have a couple of other webinars coming up. And again, some of the questions may be related to some of these areas. We had a presentation last week about the business of power, and there's a couple more here coming up. First is October 4th about connecting grids, interties. And then October 12th, some comments there on some of the renewable programs. So if those things are of interest to you, please go on and register, and you can look forward to those in October. So anyway, let's leave it there for time. Thanks to all of our panelists for joining us today, and we really appreciate your knowledge and willingness to share your perspective and experiences with us. And again, a very sort of warm thank you to all of us who connected in today at your desks or wherever this happened to find you today over the lunch hour, just to listen to the material and ask questions. This is really important. And as I mentioned at the outset, this discussion was recorded, and we'll be posting it online at sasspower.com/engage in the coming days for those of you that couldn't make it. And 2 more coming up here soon. I hope to see you at some of those coming up. And again, you can register or learn more about the details for these at sasspower.com/powertalks. And again, our engagement site is up there, sasspower.com/engage. You can follow along there for all of the opportunities to ask questions or give your input. And again, really appreciate your time today. So with that, we'll conclude the webinar. Thanks to our panelists and everyone for joining. And I hope you have a great afternoon. Thank you.